Hi guys, and welcome to this well, it's got a ridiculously long title, using a recurrence relationship to analyze, and I don't really remember. My name's Darren from Maths Guru, that's all I remember for the moment. Old age, you know, it's getting there. Pardon, who am I? Really good to see you. Thanks very much for joining this video, part of the general math series of videos. If you can, do me a favor and subscribe to my YouTube channel. Turn off notifications if you need to, but by subscribing, you just let me know you've watched, all right? And recording these videos is amazing, but it's soul destroying when no one actually seems to watch them. So if you can do that, awesome. Follow me on this brand new thing called TikTok. You may have heard of it. Yes, I'm on TikTok at Maths Guru. And if you can, leave a message on YouTube as well. Just let me know whether it's a good video or not, if it's any good or if it's been useful. That'd be greatly appreciated. Right, what are we doing today? He says, we are going to look and understand what it means to be a recurrence relationship. That is massively important. We're going to identify what a recurrence relationship looks like and how to write it, and know how to create a sequence from said recurrence relationship. Now, in the previous video, what did we do? We looked at, well, all of this has been on arithmetic sequences, and those are sequences that go up or down by the same value. It's linear when we look at it on the graph, all really important. And we came up with a formula that said we had T of n is equal to A plus n minus 1 times D. Now, this was to get to the nth term, right? This wasn't a sequence to sequence, or sorry, this wasn't a term to term rule. It was, well, if I wanted to know what the 47th number on the list was, how would I work it out? Well, if you remember, A was basically my first term, or the first number in my list, which is a bit subjective because we can choose any first term really. And D was given by my common difference. That's how much it goes up or goes down by. And all of those common differences have to be exactly the same. So when you've got a sequence, you always need to check the common differences are the same, right? And then that meant that if we were given, say, the T of 40, well, that meant that we had the value of n. And so long as I had my A and I had my D, we were sorted. And again, we would use our calculator to do that, wouldn't we? Because that would make a lot more sense. Now, then we get on to what a recurrence relationship is. And as you can see behind me, it looks pretty funky, but these are massive next year. So when we do the finance module, huge. Being able to write these, being able to read them and understand them is critically important. So with this, Barry's been working overtime. If you've got no idea who Barry is, over here in Australia is this really irritating guy who sits in a room on his own. No windows, no friends, just a Sudoku beside him. And I think it's his job to try and make maths as hard as it possibly can. Why? By coming up with the most ludicrous language he could possibly find. So it's my job to try and decode all that rubbish. How? Smoke and mirrors. Let's get rid of the smoke and mirrors, all right? In the UK, I'm fairly sure we got rid of our Barry twice. He kept trying to come back and we were like, let's just have some sensible mathematics, if you will. All right, so a recurrence relationship is basically this thing here. And again, it looks scary, but it isn't. So let's break it down bit by bit. T1, what did we say that was in our previous video? It was the first term, or where our number started for, the first number in our list. So T1 is effectively the value of A. All right, so in this situation, we would have a sequence starting with 10. Now, the next bit is really important. That comma, believe it or not, massively important. So many people forget it. So many times I get really upset. Just don't, it's a thing, it's important. It breaks it up. The comma's there. Now we get to the next thing here. T of n plus 1. Now, all I need you to do is read that as next term. So whenever you see that, just read it as the words next term. T of n is basically my current term. Now, I know we've seen that earlier on. I mean, in fact, if we look at this slide here, we've seen that here. That's the nth term. I always think of that as to get to my current term. So T of n plus 1 is my next term, my current term, and then we have this here plus 2. Well, that's actually my common difference. So that's what we need to do. So if I read this whole thing, it says to start at 10, take my next, or to get to my next term, that's the equal sign, take my current term, and I simply add on 2. Oh, okay then. So to get to each next term, take the current term and add 2. Well, if I've got 10, start again. If I've got 10, add 2, 12. Add 2, 14. Add 2, 16. Add 2, 18. A ka-ching. And realistically speaking, it looks complicated, doesn't it? Yes, but next year, as I say, it is critically important. I cannot tell you enough how many times you're going to write this down. But what is important is it is very different. A recurrence relationship is different from a rule, and people get those confused. So a current relationship or a recurrence relationship must have this t of n plus 1. It must have a t of n. It must have a t1. All of these things are really important. It's almost like an English essay, isn't it? Where you've got to have a sort of a start, a middle, and an end. That's very true in this situation as well. And being able to read these things, really, really important. Now, something else that is massively important, he says, putting his hands together, must be really important, is VCAR. VCE and VCAR are literally going to knock you marks off for the fun of it in this, because if you don't use the right terminology, if you don't do what they're asking you to, you're stuffed. So as I can say here, the word show that in maths means something very specific. You've got to show each line of working out to get to where you need to get to the answer. So if, for example, we were asked to show how to get to T5, I can't just go 10, 12, 14, 16, 18 and just write down 18. Unfortunately, I would get 0 marks. So a show that question tells you got to do this. So you start with T1 and you write 10. You say T2 is equal to 10 plus 2 equals 12. Yes, you have to show the examiner that you can do 10 plus 2. Now I've chosen pretty trivial examples here, so please don't get too carried away, but it's important. What I've got here, so T3 now would equal 12 plus 2, which would be 14. And T4 would be 14 plus 2, which would be 16. And T5 would be 16 plus 2, which would be 18. Now again, you're going to turn and say, that is a lot of chopping work. And I'm going to say, yeah, I agree with you. But VCAR are the ones who are handing out the marks. And if you ignore what they're asking you to do, you're not going to get the marks. And General Maths next year is probably harder than you think. Why? Because the questions are written in a very strange way to try and trick some of you. And more importantly, they expect and they know, sorry lads, that there'll be lots of lads out there, lots of boys out there who just won't do what they're expected to do. They'll just go 18, you've got to give me the marks. Nope, actually they don't. So in this situation here, you would have to show what you started at, and every time you do a calculation, you'd have to show your answer, and then you would have to copy that answer back in to get your next answer. All right? Silly, but that's the way it goes. So being able to read these and use them is really, really important. Now, obviously, you've also got to be able to graph these things. And in a previous video, we used our calculators to be able to graph them. So let's have a look now and see whether we can take the sequence that we've been given. What is it? T1 equals 24. So remember, what does that tell me? It's my first term. Yep. Is equal to t of n plus 1. So to get to my next term, I take my current term and subtract 2. Okie dokie. Right, so to get to the next term, I take my current term and subtract 2. Now I can do this in lots of different ways. I'm going to start with 24. So that's my first number. And I'm going to then, I'm going to take away 2 to get to my next number. So that's 22, 20, 18, and 16. Now the question says, generate and graph the first 5 terms of a sequence. Now with this situation, what you got to remember is this here is T1. So if we have our graph here with my term, and here is my number or my sequence number, am I going to start on the 0? No, why? Because my T1 tells me that I'm actually going to start at 1 horizontally. So 1 is going to be up here at 24. Now, another word of warning for your VCAR exams, or in fact exams. All right, again, I keep having to go at the boys here. I'm so sorry, but you know, I know that many of you will grab a pencil and go, oh, me got pencil. Me just put it somewhere on here and hope. You don't just hope. If you draw it in pen, you get no marks, all right? Pencil all the way. VCAR get very upset if you don't draw pencil. Why are you drawing a pencil? If you make a mistake, you can erase it, all right? Make sure the pencil's relatively dark though by the time you get your exam finished. So there we go, 24 was my first number. Then what I'm gonna go, my next number was 22. So I'm gonna go 22 and I'm gonna do a cross. My third number was 20. My fourth number is 18. And my fifth number is 16. And there we go. Job done. Would I join those together? Probably not in this situation because we're not having sequence numbers of 0.5. And again, knowing when to join these together, really, really important. So have I got my marks there? Yes, I have. Use a rule to calculate. Now, again, remember this here was a recurrence relationship. It is not a rule. My rule would start with t of n equals. Hold on, this is an AP. We're adding on or we're taking away the same value. So I can use a plus n minus 1 times d. Right, what do we want? We want the 33rd term. So there's going to be t, 33 is equal to, do I do know my first term? I do. It's 24. Plus the number of terms, oh, we got it here, 33. Minus 1 times my common difference. What's my common difference? Again, remember, it was this number here. It is minus 2. Not 2. Again, people make mistakes here. Now, what am I going to do here? I should cocoa. I'm going to fire up my calculator. I know it's covered up my working up. Let's see whether we can go back to a previous screen. And so I'm just going to type that in. 24 plus, what is that? 33 minus 1 times by, in brackets, minus 2. Hit enter. And there we go, minus 40. So in that situation, I would write minus 40, job done. I'm a genius. All right, now again, it's really, really important here to make sure that you understand the difference between a rule, and your rule will start with t of n, and a recurrence relationship, which is the one above. All right. Now, how do we apply this in a bigger context? Well, it's not different, to be perfectly honest with you. We got an example of snake shapes below are made using blocks, each with a side length of 1 unit. Okay, thank you very much. So what that means is that here is my block. That's 1 unit, that's 1 unit, that's 1 unit, and that's 1 unit. The perimeter. Do you remember what perimeter is? Why am I waiting for you to answer? That's a bit weird. Is the distance all the way around the edge of each shape can be found by counting the size of the blocks around the outside of the shape. The perimeter of each new snake built is 6 units longer than the previous snake. Let Pn be the perimeter of the snake of shape n. Right? So n's going to be 1, 2, 3, 4, 5, and Pn is going to be the perimeter of that. A recurrence relationship that models that is given by, right, so what do we got here? P1 equals 10. That's my first term. So let's just check. Is my perimeter of my first shape 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it is. Ka-ching. P of n plus 1. To get to my next snake, I am going to take my previous snake and add 6, he says. Why am I adding 6? I just want to check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh my goodness, there we go. And I guess if I did snake 3, I'd be exactly the same thing. Right, so if we work through the questions, I'm going to do a lot of this on my calculator if that's okay. What does P1 equals 10 tell us? It tells us the perimeter of the first shape is 10 units. Ka-ching, thank you very much. They're not asking you to say it's the first term, they're asking you to say the perimeter of my first shape is 10 units. What does the rule in the recurrence relationship tell us? Well, again, they're telling us here, I suppose the rule, yeah, is that for every shape, our perimeter is going up by 6, right? So for every new shape, our perimeter, or snake, I suppose, our perimeter is going up by 6. Second bit wrong. Use the recurrence relationship to generate the perimeter of the first 4 snakes. Right, we can do this. Let's fire up my calculator. I'm actually going to go back here. Now, I'm going to show you, I could just delete or reset all this, but I'm going to delete all my values. See what I'm doing here? If you go up to the top and just scroll, press up once, you'll actually highlight the whole column and you can delete that information. Job done. Right, what am I going to do now? Right, I'm going to put n for my snake number, and I'm going to put P for my perimeter. Now you could make it longer if you want to. I don't see why I would. So my perimeter numbers, or my ends, are going to be 1, 2, 3, 4, because it wants my 4 snakes. Do I know what P1 is? Yes, it told me in the question. It was 10. So that's going to be 10. Now what is my rule? Add 6 each time. I can do that. Now what I'm going to do is I'm actually going to show you what I did at the last lesson to show you how to create this rule. I'm going to put equals. And I'm going to say I want the cell reference of the one above it. Equals says start a formula. So I'm going to do the 10, which is in B1. So I'm going to do B1, and I'm going to add on 6. There's my rule. So I've added on 6. Now I could keep just adding on 6 in my head, but I'm going to go Menu, Data, Fill, and I'm going to go down. So you see those dotted lines go down. I hit Enter. And there we go, there are the first 4 things. Now, obviously, you would then write these down on your piece of paper. So what would I do there? I'd have N, and I'd have P. I'd have 1, 2, 3, 4, and I'd have 10, 16, 22, and 28. All right, to construct a table. All right, so in yours, you would actually copy that in as your actual table. And again, sorry, my calculator's covering this over. Use the table to plot the snake perimeters. Now again, on yours, you would draw a nice set of axes and you would plot it. I am very lucky that I can actually flick my calculator over and you go, hold on a moment, that's not right. Nope, because my calculator is trying to plot the wrong thing. So I'm going to go N along the bottom, and I'm going to do P up the side, and that sounded minorly inappropriate. It sounded a bit rude, P up the side, don't P anywhere. That's going to get me banned from a number of schools. And there we go, there is my graph. Now what you've got to notice here is that on my calculator, I actually start at 0.8. Would yours start at 0.8? Probably not. We'd probably want the calculator to start at 0, and likewise here, we'd probably want that to start at 0 as well. That's effectively what you're going to do. Your calculator is just trying to be really, really clever. And there we go. That is my table, all right? And I've plotted it. I'm not joining it together. We don't join it together. Use the rule for the nth term of this sequence to predict the perimeter of the 50th snake. All right, well, I can do that. Let's turn my calculator off for a moment. So the nth term, well, again, we're going to go here. My rule is T of n is a plus n minus 1 times d. Right, so we want t, what do we want? We wanted the 50th snake, so there's 50. So a, what is my first term? It is 10 plus n, which is 50, minus 1 times my common difference, which was 6, plus 6, because we were going up 6 in each case. So it's trying that, it's going to be 10 plus 49 times 6. I'm going to bring up my calculator again just so that I can actually use that, and I know it's going to cover my working out over, but that's right. So 10 plus 49 times 6 gives me 304, and so we would write there 304. Now again, I could have done this over numerous screens, but the point of it is I was trying to fit it all on the one. You would actually set this out, and if it was an exam, you'd have loads of space in which to be able to do this. But the good news is I am finished this particular video. Has it gone on for long? Nearly 20 minutes. Well, 20 minutes of excellence. Thanks very much for watching. Hopefully it's been useful. Tell your mates. Subscribe to me on YouTube if you can. Again, it means the world to me. I know that probably sounds really pathetic and needy. It really does mean the world to me. Likewise, TikTok. Sign up to TikTok. Just follow me. It just shows, hey, it's worthwhile doing these. And also, hopefully, I'll see you in other videos. These notes are available on maffsguru.com. Download them. All right. Otherwise, hopefully I'll see you in another video. Take care, guys. Bye-bye.